Hello lads and welcome back. So we're continuing on with our algorithms and our pseudocode, and today we're going to look at how you translate the pseudocode into flow diagrams. Okay, so we've all seen flow diagrams, but maybe we haven't explored exactly what they look like in terms of their structure and what the actual different parts mean. So the first thing we're going to do is we're going to look at what the flow diagram means. Diagram is kind of a pill-shaped block, okay? And this always represents the start or the stop, okay? The beginning and end of the algorithm, okay? So it's in a box with rounded corners, so pill-shaped, for want of a better word, okay? The next most common shape you're going to find is going to be a kind of a diamond shape. Okay, and this is what's called a decision block. Okay, and a decision block is often a yes or no Boolean type scenario. Okay, so when you come across it, it's a yes, is it a no? If it's a yes, you go one direction. If it's a no, you go another direction. That type of thing. Okay, so it's a decision block. So that's the second most common one we will come across. Okay. The third most common one then is going to be, well, I suppose it's called the parallelogram box. Okay, some people call it a rhombus, whatever you want. But basically, it's going to be your input, output box. Okay, so this is where, you know, any inputs will go in, integers, strings, whatever, and then it'll also be used for any outputs are coming out, you know, results of an equation, results of a search algorithm or anything. So anything that goes into or out of the algorithm goes into the parallelogram box, okay? You will also see a rectangular box looking like this sometimes, and this contains what's called a subroutine, okay? So a subroutine is going to be, I'll use a different color for this one. A subroutine is going to be like a subprogram. So it's a subprogram. And, you know, what you could have is the subprogram could link to another program, but they've just put the subroutine in there. So you could have a, let's say you could have an algorithm that, you know, adds up numbers, and then in the subprogram, you could put it in somewhere where, you know, if you make a particular decision in an algorithm, it might multiply the numbers, but you don't want to write the whole algorithm for multiplying. You just the addition algorithm, and you just put the subroutine, and in the subroutine will have the algorithm for, you know, multiplying. Where you'll see that in Python is a function. Remember our functions. Functions would be like a subroutine, okay? It's another that's built into a bigger program. Okay, and it can be called and executed very quickly and saves, and it's efficient, and it can be reused. Okay, and a rectangle without the inner rectangle is called a process. Okay, and these are, you know, the calculations, the instructions, whatever that has to happen in order for something to take place. Okay, so there again, it's a very important piece of kit. And finally, you need arrows. And arrows tell you the direction of the flow of the information through the algorithm. Okay, so these arrows show the direction of data. Okay, so when you put all these together, you get your flow diagram. Now, in more complicated third level stuff, there are other bits and bobs that you can have, but for leave insert, this is all it's going to be. Okay, you're going to have pill-shaped start and stop. You're going to have diamond-shaped decisions. You'll have input outputs that are parallelograms. You'll have processes, which are square or rectangles, and then you have a rectangle inside a rectangle, which is a subprogram. And then, of course, you've got your arrows showing the direction. So what I'm going to do is, if you remember from the last video, we had a look at the pseudocode, and pseudocodes we had a look at was how to calculate a 20% increase in your pay. So what we're going to do is we're going to use this structure to convert our pseudocode into a flow diagram. So I'm going to have a look quick yesterday. Sorry, I did a bit of doodling up on the side when you get bored. So let's have a look at our pseudocode from yesterday. Okay, we were asked to write an algorithm that calculates pay after a rise, and we gave two examples of how to do this. The first example was a very simple pseudocode: take original pay, multiply it by 1.2, show me answer. And when you followed it, you know, if you knew what you were at, you know, you'd be okay. The problem was it was still a bit vague. Take original pay. Well, do I take the pay as an integer? Do I take it as a string? Do I take it as a word? You know, so that was very vague. So we clarified it into a bit more structure, and this was the type of pseudocode that would be required. We define pay as an integer. We define pay as an input, which is stored as a variable. We create a new variable where the other variable is multiplied by 1.2. Made a mistake yesterday. And then we print the new pay variable. So that was a more, you know, stronger or a more fleshed out pseudocode. So we're going to use this one, and we're going to apply these rules to it. Okay? So that's what we're going to do. So I'm going to go a half and half on this, if that's okay with you. So bear with me. So here we have our pseudocode. I'm going to trap it up there. Now we're going to try and turn this pseudocode into a flow diagram. Okay, so we're looking for a 20% increase. So we need to start, don't we? So we need our pill-shaped start. Okay, we need some information flow. So this is the direction the algorithm is going to take. So what do we first thing? Okay, we need to input something, don't we? Okay, so what's an input? Input is a parallelogram. So input pay, original pay. Okay, so there's your input. Okay, so anyone in the world, you go to China, you go to India, you go to Brazil, you go to Australia, you go to Newcastle in England. If anyone knows their computer science, even if they don't know what those words mean, they will know what those symbols mean. Start, some type of input. Okay, well then what did we do with the input once we got it in? Okay, we're going to have to do some type of calculation. So remember, some calculation, that means some type of process, and process involves a rectangular box. Okay, so what are we going to say? We're going to say new salary or new pay is equal to original pay times 1.2. Okay, so there's my process done. Now what happens after process? Well, we need to output it, don't we? Print. So we're going to output it. So that means another parallelogram box. And this parallelogram box is going to, what do we say? New pay. Okay, output new pay. And then do we just leave that hanging? No, we stop the algorithm. Stop. And there you have it done. Okay, so hope you can understand that one. Okay, now this is the good point. We're going to try it now with the other one from yesterday. So if you remember from yesterday, we had this little beauty. This, remember, password checker? Now, let's have a look at this original one for a second, because when we have this all done, we'll have the password checker on this side, and we'll have a look at the two of them. But this is what's called a sequenced flow diagram. Okay, so a sequenced flow diagram, there's only one way to do it. Only one way to get to the end. Okay? There's no other way I can get from start to stop except go through all that. Okay? The next one we're going to look at, you can see it from the pseudocode. We have some conditionals, which means there are possibly other routes to get from the start to the finish. Okay? So we'll have a look at this one now, and we'll see where we can go with it. So just bear with me while I do make a couple of little movements on the page here. Fold this one in half so I can have it beside me. And I'm going to shift this one over. So I just want to have it side by side. So, hope you can all see that. So this one was a pseudocode that created a 6-character password, but it also checked that the password was not the username. And it gave you a couple of prompts as to what to do. So let's have a look at what we need to do. Well, listen, obviously we need to start it. Okay, so let us start it. We'll start it here. So, okay, so we need a start. So we're going to need some information. So there's going to be a flow of this algorithm. And the first thing we come across is an input. So we have a double input. Now you could put 2 separate boxes, but because one box doesn't determine the other, they both really have to happen in order for it to happen. It's easier just to put one input and just tell the input that it's going to be input, username, and password. I hope that makes sense here. There's no point in saying input username and then another one saying input password, because you know it's not like this where one needs the other to happen. The algorithm for these, you can put them side by side and put a plus, but the flow diagrams don't work that way. So it's just easier to have, if you have multiple inputs that have to be put in at the one time before the algorithm can progress, you can put them all inside the one input kind of flow diagram box. Okay, so we've got our input now. If the length. Now, if. What does if mean? Isn't that a decision? So now this is where we're coming to our little diamond. Okay, so we have the decision. If the length is less than or equal to 6, okay, well, if it's a yes, what's going to happen? Well, didn't we we had an output, didn't we? Okay. We had an output, and that output said too short. Try again or whatever. Okay. So, and what happened if it wasn't less? So if it's no, well then we had another decision, didn't we? We had to check that the password was not the username. Our password and username the same. And if it's a yes, well, same thing. We need an output just saying can't be the same. Okay, so, and if it's a no, well, we have another output But this output says password. Okay. Okay. Now, what have I not done here? I haven't finished it off. Well, all three will come to the same conclusion, won't they? No matter what happens, because I haven't told it to go back and try again in either of these scenarios. We didn't say that, okay? This was a very simple condition where we kicked you out if you didn't, and we only let you go through if you did. So look, I'm kicking you out if you didn't, but I'm letting you through on this last one if it passes all the other tests. We're still going to have to put in a stop. Wow. So let us now have a look at both of them. So this is my sequenced one. This one is called a selection flow diagram. Okay, and obviously because there's multiple ways to get from start to stop. And there are. Okay, so you can see that now. So let's go through it again. Let's do our checklist. In our sequenced, I have a start and a stop. These are my pill-shaped boxes. We have a number of inputs and outputs in both of them. We have a process here. No, I noticed here we don't have a process. Did you notice that? We didn't have a process in this one because there was nothing to be calculated. We were just checking. The process was taken over by this decision block. This was, in want of a better word, the process. But when, the decision block is very blunt instrument. It's a yes or no. It's a Boolean statement, really. Okay? It's your if statements. Okay? Plenty of outputs, depending on what decisions were made, and then a stop. So that's your second type of flow diagram. Definitely more complicated, one that you're more likely personally to see. Okay? Now there is a third type. Okay? There is a third type. Okay? And what I'm going to do about the third type, you can already tell what the third type is. It's the one we haven't dealt with. It's the one where you got the loop. Now, I am hesitant to do it now because A, I don't have enough space, but B, we're better off doing it with an example. And the two examples I've given so far, you can't use for a loop, really. Okay? I'm going to do a very simplified version of it just to kind of get your ideas on it. And then you can see for yourself. No, actually, no, I'm going to leave it. Okay? No, I will do it. I am going to do it. Right. So here's the third type. So I'm just going to do it and we can talk about it. Third type is obviously called an iteration or a looped flow diagram. So we'll do a simple one. Do a start. Okay. And let's think, we'll do a linear search one. Okay, so for those of you who don't remember, a linear search is where a computer goes through a set of a string or numbers and searches for one that they want. So let's say I had A, B, C, D, E, and F. Okay, inside in a list. A linear search would just go and check. If I wanted to find D, it would go and check, is that D? Is that D? Is that D? Is that D? Yes, it is. You found it. Okay? That's what it would do. Okay? So, let's see. You start. Okay? So, let's think. First of all, we need, think about it. We're looking for D. So, we want D is going to be some type of variable. So, you're going to input a variable. Input a search parameter, let's say your D, and then you're going to ask it to check, is this D? If it's not, move one over, check, is this D? If not, move one over, check, is this D? So there's going to be decisions being made here, okay? So let's have a look. you're going to have some type of decision, first of all. Okay. Let's think. We're going to have a decision. And then let's say we'll move on. We'll have to have some type of process. And then we'll have to have another decision. Now, why I'm saying a process, because a decision will decide whether this is or not is D. But then we need a process to move to the next one. Does that make sense to you? So that's why in my head, I'm kind of planning it out before I put in my parameters. I'm definitely have to make a decision about A, and then a process that moves it to B, then a decision around B, and then you get the idea. And this is where the loop then will be built in. Okay. So if we do eventually get to it, then we need some type of output, and then probably a stop. Okay. Item found. Stop. Okay. And right. No. Right. So I'm building it back up. So if I find the item, if it's D and the decision is yes, my output will be item found and it stops. If the decision is no, then I have to go right back up, and this is where I'm going to have to. Now, I think this will work. So let's think about it. Okay. I'm going to do two scenarios. Okay. One scenario where that's what's put in. I'm looking for D. So I'm looking for D. Okay. So I'm going to check this one. But remember, the whole point of algorithms is you have to check all possibilities. Here's my other possibility, where I just have that inside the list, nothing else. Okay. So this is my premise. I'm looking for D. I have to create an algorithm that will work for both of those. So let's check the algorithm if I run it for this one. Start. Are there more items? Okay. No. No more items. Okay. So there has to be an output. D not found. And obviously that's just going to kick right out. And I'll go straight to stop. Okay. So that covers any possibility where D isn't in a list, because when this loops, if there's no more items, it could keep going forever looking for D unless it said no more items that you've checked. No, D not found, out. So let's assume now we're looking at this one. Okay. So let's start. We go in. Are there more items? Yes. Check the next item. Yes. Is this D? No. Go back. Are there more items? Yes. Check the next item. Okay, it's not D. No. Go back. Same thing. Are there more items? Yes. Check. No. Move. And then it catches it on that one. So this is what's happening all the time. Now, if we were to put it into some type of loop, you could do a for loop for I in range, 0 to x to the length of whatever list this is, okay? If your variable you're looking for is equal to d, print item found. Else, move the indice 1 and check again, and it'll just keep moving and checking again and again and again. Okay, so this is called an iteration flow diagram. Okay, so it's definitely the most complicated compared to the rest. If I compare it to the rest, I don't know if I can get all three onto the one page together. Hope I can. Just about there, I can. It's definitely the most complicated of the three. Okay, that I was hesitant about doing it, but I'm better off doing it now in case none of you ever look at any of these videos again. At least you'll have seen an iteration flow diagram. We will come across and look at it in more detail when we actually do a linear search in terms of the algorithm of how you do a linear search. Okay, listen, I've gone a bit over today. I've probably fried your brains, but that should keep you going. Thanks a million. Bye.